Why are halogens colored? Now this is lovely. Why is any substance colored? Any substance appears to be colored to human eye because it absorbs certain wavelengths from visible spectrum. Now why should a halogen absorb any wavelength from visible spectrum? For this, my dears, you have to look at the molecular orbital diagram of a halogen molecule. Let me give you an example of F2, and you can generalize this for any other halogen. Let me write down the MO configuration. It is sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2. It is standard. Then you have sigma 2px, pi 2py, pi 2pz, pi star 2py, pi star 2pz, and then sigma star 2px. What I'm writing down is the electronic configuration of fluorine. In case you wish to talk about chlorine, bromine or iodine, instead of principal quantum number 2, this would become 3, 4 or 5 respectively. All of the things would, with some modifications, remain similar. So if you just look at this, this is highest occupied molecular orbital. And if you look at this, this is lowest unoccupied molecular orbital. This is empty, this is filled. And whenever light falls on this, you find that electrons from here jump to this orbital. And in this process, if the energy gap between this highest occupied MO and lowest unoccupied MO is small enough to belong to visible spectrum, you find that they will absorb visible photons and make a jump here. In case of fluorine, they absorb violet photons and they jump. And if you look at the color wheel or color chart, the complementary color of violet is yellow, and that is why fluorine appears yellow in color. As you move down the group, you find that the energy difference between highest occupied MO and lowest unoccupied MO decreases. As principal quantum number increases, you find energy gap decreases. So this excitation becomes relatively more easy, and the color of halogen keeps on becoming more and more intense on moving down the group. This, my dears, is the most accurate explanation of why halogens are colored.